Welcome to Krista McAuliffe Academy's second 7th grade math instructional video about fractional rates. As in our first instructional video, students should use the Cornell closed notes provided by the teacher while they watch the video, filling in the missing word or words. After filling in the missing information, students should write a question for each box or chunk of information that will help them connect with the key concepts and terms. The day after taking the notes and writing the questions, the student should answer each question using complete sentences in the summary section of the Cornell notes. Module 1, Topic 2 is fractional rates. Our learning objectives: students will determine ratios and write rates, including complex ratios and rates. Students will determine and compare unit rates. Students will write and solve proportions using equivalent ratios and means and extremes. The math standard that we are addressing is 7RP. Analyze proportional relationships and use them to solve real-world problems. Why we are learning this: proportionality is just a fancy name for the multiplicative relationships that shape our world. If one bag of chips costs $1.25, then 2 bags of chips cost twice as much. Being able to write ratios, rates, and proportions is a strategy to determine unknown quantities successfully. How will we know if we are successful? We will know we have achieved the math standard if we can set up and analyze proportions, and if we can solve for the missing information. Ratios. We have seen ratios before, and we know that they can be written in different ways. We can have 8:2, which means 8 to 2. We can also write a ratio as 8/2. And remember, a ratio written like this is also a division problem. So 8 divided by 2 equals 4. A ratio compares the amounts of two quantities. For example, there are 8 cups of sugar for every 2 cups of flour in the cookie recipe. Rates. Rates are ratios with units. So what we have here on the left is a rate written in 4 different ways. 12 bracelets made in 3 hours. That tells us specifically what's going on. Underneath that, we have 12 bracelets colon 3 hours, which means what we've written underneath, 12 bracelets to 3 hours. Under that, we have our rate written as a fraction, 12 bracelets over 3 hours. A rate compares the amounts of two related quantities, and it's a ratio with units for both quantities. For example, there are 12 bracelets made for every 3 hours of work. The units here are bracelets and hours. From rate to unit rate, scaling down. Sometimes we must scale down to find the unit rate. For example, if I worked for 3 hours without stopping and made 12 bracelets, how many bracelets do I make per hour? Well, I can set up the given rate, 12 bracelets over 3 hours, and I can set it equal to some number of bracelets over 1 hour. To get from 3 to 1, I need to divide by 3. So I'll also do that in the numerator. 12 divided by 3 gives me 4 bracelets in 1 hour. The unit rate here is 4 bracelets per hour. Sometimes we have to scale up to find the unit rate. For example, if I work a half an hour and make 2 bracelets, how many bracelets do I make per hour? Well, I can set up my original rate, 2 bracelets in a half an hour, and I want to multiply here to get to 1 hour. 1/2 times 2 gives me 1 hour. So then I'll also multiply by 2 the numerator. 2 times 2 equals 4 bracelets. So the unit rate is 4 bracelets per hour. Proportions. A proportion is just two rates that are equal to each other. So we have in the green box 24 bracelets over 6 hours, and I've set that equal to, in the blue box, 8 bracelets over 2 hours. I know that these are both equivalent because when I evaluate the green box, 24 over 6, 24 divided by 6, I get 4. And when I evaluate the blue box, 8 over 2, or 8 divided by 2, I also get 4. Both sides of the equation have a value of 4 because both ratios, the one on the left and the one on the right, are equivalent. Just a note, to set up your proportions, you're going to want to use your units to keep the same item first in both ratios. This is going to avoid confusion and increase success. To solve a proportion means to fill in the missing information that will make the two ratios equivalent. So I have taken the example from the previous slide, and I have removed the value for the number of bracelets in the blue box. This is the type of problem that you'll be expected to solve. A proportion is essentially two fractions that are equal to each other with a total of 4 numbers that exhibit parallel multiplicative relationships based on their position in the proportion. Now, to solve the given rate up here, the given proportion, I can look down here to this green box. So if, as within the left-hand fraction, the numerator is 4 times as large as the denominator, because 6 times 4 is 24, then the same will be true within the right-hand fraction, the blue box. The missing value is going to have to be our denominator 2 times 4, which equals 8. So we get 8 bracelets in 2 hours. Solving proportions using means and extremes. We can use the following relationship to solve a proportion. The product of the means is equal to the product of the extremes. What we need to do is set up our rates so that our units are in the same position. So I have bracelets in hours, bracelets in hours. I have 24 bracelets, that goes with 6 hours, 8 bracelets, that goes with 2 hours. Now I can take these two middle numbers, my 6 and my 8, and I'll call those my means. My extremes are going to be my outside values, 24 and 2. And what the relationship says is that the product of the means equals the product of the extremes. Product means multiply. So we're going to take our extremes, 24 times 2. That equals 48. We're going to take our means, 6 times 8. That also equals 48. Because I get the same product for the means and extremes, I know that my proportion is correct. So if one number is missing, what we can do is set up an equation using a variable to represent the unknown number and solve. This is the same example we've been looking at. The setup, 24 bracelets with 6 hours. I've taken out the value for the bracelets that go with 2 hours. Since we still have our extremes, 24 times 2, that equals 48. And we know that that needs to be equal to 6 times some number that I don't know yet. So I can represent that unknown number as x, and I can write 6 times x is going to have to equal 48. And I know if 6 times some number in 48, then that number is going to have to be 48 divided by 6, which is 8, the number of bracelets I can make in 2 hours. Solving proportions using cross multiplication. Cross multiplication is just another way of using the product of means and extremes to solve a proportion. To use cross multiplication, we're going to set up our rates as fractions. So we have 24 bracelets over 6 hours is equal to some unknown number x over 2. What I'm going to do in cross multiplication is I'm going to multiply these two, 6 times x. I'm going to multiply these two, 24 times 2, and I'll set those two products equal to each other. 6 times x equals 24 times 2. 24 times 2 is 48, so we end up with exactly the same equation as we did using means and extremes. 6 times some number is 48. And we know if 6 times some number is 48, then that number is going to have to be 48 divided by 6, which is 8, the number of bracelets I can make in 2 hours. Complex ratios and rates have fractions as either one or both values. So for an example, we often have recipes that have partial cups and partial teaspoons of ingredients. So our example, 1/2 cup of milk for every 2 cups of coffee. And I can write that rate as a fraction, 1/2 cup milk over 2 cups of coffee. I can set it equal to some unknown amount of milk over 6 cups of coffee. Can you solve this proportion? How many cups of milk do I need for 6 cups of coffee? Unit conversion rates are ratios of equality. So you have here on the screen example 1, 12 inches over 1 yard or 1 yard over 12 inches. These are conversion rates because 12 inches is equivalent to 1 yard. Example 2, we have 1 inch over 2 and 54 hundredths of a centimeter, or the reverse, 2 and 54 hundredths of a centimeter over 1 inch. 2 and 54 hundredths of a centimeter is equivalent to 1 inch. So these would be our unit conversion rate between centimeters and inches. Let's see how we can use those to solve a question, solve a problem. We can use conversion rates to change a measurement in one unit to a measurement in a different unit. For example, from centimeters to inches. So let's say that we start with a measurement of 135 centimeters. Let's say I measured how tall you were in centimeters, and I found you were 135 centimeters tall. But because we think more frequently in inches, we want to convert it to inches. So I'm going to take my 135 centimeters and I'm going to multiply it by the conversion rate, 1 inch over 2 and 54 hundredths of a centimeter. Now, 135 times 2 is definitely not 53. We need to remember how to multiply fractions. We are always going to multiply our numerators together. We're going to multiply our denominators together. Then we're going to divide our numerators by our denominators. So 135 centimeters doesn't look like a fraction, but we can make it a fraction by putting it over 1. So we'd have 135 times 1 in our numerator and 1 times 2 and 54 hundredths in our denominator. What we end up with will be 135 divided by 2 and 54 hundredths, which gives us 53 and 15 hundredths of an inch. As long as we set up our conversion rates so that the units we don't want cancel out and the units we do want are left, we will be successful. In this example, it's the centimeters that are going to cancel each other out. Just like if we had a 5 in the numerator and a 5 in the denominator, 5 divided by 5 is 1. We can use that same concept. Centimeters divided by centimeters is going to be 1. So our centimeters cancel and our inches are left. In the example above, a person who measures 135 centimeters tall is a little more than 53 inches tall. Big ideas to remember. Fractions are our friends. Fractions are very useful in math, and as long as we review how to work with fractions, we are going to be successful. Fractions can help us understand proportional relationships. They can help us determine missing quantities. And last but not least, fractions within fractions are okay. We can make sense of them. We can do this.